Hey, Sai.
Yes, sir.
There's echo.
Hello, sir.
Hello, hello.
Sir,
Can you hear me?
right now it's okay?
Yeah, much
Yeah,
better. Yeah.
let us start at 7 o'clock, sir. Remaining students also join.
Yeah, that's fine. Yeah.
Yeah,
So
okay.
I joined a bit early. If there is any
Yeah,
technical
yeah,
issues
okay.
which we had, yeah. So, so right now, what kind of students are here? Like, it's a mixed batch, or like, do you know them, or like,
So,
which year?
it's second years and third year students are joined up to now.
Okay,
Yeah, remaining, like only those 2 year students are joining, I think so.
okay,
Because first years, I think they know have some exams.
okay. They have
Yes.
exams now as well. Oh God.
Yeah, mid exams like that. There's some midterm exam.
Okay, so mostly second year and third year over here.
Yeah, yeah.
Okay. And which stream, like engineering, like computer engineering or something?
Engineering, computer science department.
Most of them.
Yes, most of the students are from computer science and AIDNC. AIDS is a separate branch in our college. So
Yeah,
from
I
the
know. Yeah, I got to know that when I went over there. So yeah.
those students also join.
Oh, okay. That's nice.
Yeah.
Do let me know if you can see my screen.
Yeah, it's visible, Rehan.
Yeah, great. And if you find any questions, if somebody asks any questions, okay, do interrupt me in between itself.
Okay, bro, okay, Rehan, sure.
Don't wait for the end. Okay.
Yeah, okay, Rehan.
Then let me know when to start because it's 6:57.
Yeah, yeah, I will.
Yeah.
Yeah.
Hey, Sai.
Yeah, Rehan.
Yeah, should we wait for a few more minutes or like
Yeah,
what?
let us wait for another 2 minutes. Actually, the strength is very low. That's fine.
Yeah, yeah, that's fine.
Yeah,
It's Sunday evening, like 7 to 9.
yeah, understand. We can join. So let us start, Rehan. Remaining students also join. You can join.
Okay, sure.
Yeah.
Hi all. So okay, I will start with a basic introduction, but before that, so today's topic, which I will mostly cover, so try to make it a bit interactive. I know it's tough over online calls, but the main topic for today will be rise of AI through deep learning. The over here are hello, can you hear me?
Yeah, Rehan. It's perfectly all right.
Yeah. Okay, great. So the thing we're trying to cover today is mostly the recent advancements in AI. What are the different places where one can work in artificial intelligence, data science, machine learning, some basic differences between these terms. And if you want to explore some of the areas, you can pick up some of the subcategories from here, which I will show going forward, and you can start from there. So there will be some kind of explanations and like mostly like the new deep learning things which is happening. So I will also cover the basics of very basic of deep learning, neuron, all those things, so that it's easier to understand like how tough this is or what are the different kind of advancements over here in this field. So starting with the basic description of myself and which I generally like to give. But yeah, so I'm a data scientist at Vodafone. I manage around five here. As I do, I am a published author. So on machine learning topic. So this is a machine learning cookbook with Python. So this general is if somebody is onboarding to machine learning or a manager who wants to transition to become a machine learning manager or similar, and if they want to know some insights, this is more of a practical book than a theoretical book with a very less maths, like as much math as required. It's not that much. So this is the book all about. If you want to know more, we can talk this on a later part towards the end, maybe. I contributed flow and I have contributed an entire optimizer over there. I worked with Arizona State University with NASA on a Mars rover project. So that was the competition over there. So which actually is a drone based machine learning. So I will talk those over here as well. and I do give lectures around multiple universities in India. And I have multiple publications, both patents as well as journals over here as well. So, yeah. Now, coming to machine learning, deep learning, AI. So, for now, I will use all these terms interchangeably. So, if somebody is aware of it, what are the differences? Well, and very good. But for now, I will use these terms interchangeably. So, nowadays, in this modern era, whatever you use from morning to night, we generally are surrounded with machine learning and deep learning and AI, all three in different forms. So let's take some examples where we see applications of AI are. If we take YouTube, so YouTube have multiple applications. Let's talk one or two. One is the video recommendation. So it actually knows your style of watch. Say if you like to watch news, or if you like to watch sports, or if you listen to music videos or similar, YouTube prefers or tends to give those kind of recommendations. So this category, you can say, if you can see, you can see this category as recommendation engine. So RC engine. You can see this category as recommendation engine. Okay. So previously recommendation engines were trivial in nature or traditional in nature, as in they use the mathematical or a statistical concepts to compute what is the next video, music video, or news you would prefer. But nowadays, it's we use something known as this reinforcement learning. Okay, so this is something extremely new in deep learning. We use this particular method. Now, coming to another application, that is Uber. Uber has Uber, or you can take Ola in India as well, or Rapido, any kind of travel-based things. They have multiple ways of using machine learning or artificial intelligence. The one major way is the price forecast. So whenever you have something, say point A to point B, you're going to point from A to B. They have a say fixed price X. But at currently, you will see there are surcharges 1.5x, 1.2x. That entirely depends on the weather. Like how is the weather right now? If it is rainy, the demands of the cab is higher, then the surcharge will be around 2.5x. I got highest till 3x. That's extremely high. But that is how surcharge works. So similarly, there are other predictions as well. Say there are, let's consider there are 100 cabs. So, and it is distributed over an area, uh, say X comma X. Let's take a very simple example. So how do you want to distribute this 100 cabs over this area so that most of the cabs will be booked at that particular time? So let's take an example. During the end of college, end of office, that's a particular time, right? So maybe 6:30 the colleges gets over or the offices are wrapped up. So around this time, you will see most of the Uber drivers, Ola drivers, Rapido drivers are around the office or the college area because they know that is the peak hour. Okay, so that's how they kind of forecast which location will have more request, like as in a drive request or a transport request. That's how they distribute the cabs over there. So this is one example. And if you have any questions, directly throw the questions and I'm ready to answer them as well. Now, next we are coming to email. Email, it's a very classic example which whenever somebody starts with machine learning, you will hear something known as naive Bayes theorem, NB, a naive Bayes theorem. Okay, so this particular theorem is a very classical approach to solve whether a particular message is a spam or not a spam. Spam means it's a junk message, say it's a tele ad or email marketing, or there are other advertisements or scams as well, which happens over email. So those are tagged as spam. and the other one which comes to your inbox is tagged as a good mail. So that's readable or it's sent by someone. So I guess spam filter is a very traditional application, but recently, if somebody uses Gmail specifically, there is something known as smart reply. Say if somebody, if you receive an email, by default you will see a reply back text. Say you have received a mail, say thank you, I have received certain amount of money from you. Automatically the Gmail will give a response that is welcome, it's my pleasure. So that message is automatically generated by Google. You are not typing it, you're just clicking it and sending it. So that comes under NLP, and that mechanism is called as a smart reply. So that happens over LinkedIn as well, if somebody have used that before. Now coming to Google Maps. Okay, Google Maps is bit tricky, but it's a very complicated graph over here. The Google Map is a highly advanced deep learning is used over here. So if you ever have used Google Map, you will know it can tell you the traffic congestion, time from point A to point B, like considering the fact in what vehicle you are in, what speed you are traveling, is there any traffic congestion or not? So there are multiple factors. What's the weather? Is there any roadblock or not? So there are around, at least for the general users, there are around 15 points which I can bring up, by which you can say or they predict at what time you will reach a certain destination from source. So this is a great application of deep learning nowadays. They try to predict the traffic as well. Traffic, I mean the roadblocks, jam, if you consider that as traffic, or one ways. That's somebody has to register that this road is one way from this PM. So this engine, if you consider this as an engine, okay, this engine is a mixture of rules plus machine learning slash deep learning. So that's how most of the modern machines work. Uh, so it's a mix of rules where you will have certain rules, a binary rule where it will say yes or no, and it will be a combination of a machine learning model. Now coming to the next one, speech recognition. If you have ever used Siri, Google Assistant, Alexa, or any others like Samsung has Bixby inside their phones, so all are kind of speech recognition. So this is speech recognition by itself is a deep learning problem, but just speech recognition doesn't make any sense. So speech recognition with NLP makes sense. So this NLP you can, so this is also an NLP problem. So NLP is nothing but natural language processing. So whenever if you give a text to a computer, it will understand what you are trying to figure it out. So that is the, if I say it in a very basic way, that's what NLP is. So now coming to the next point, do you have any questions so far? Any questions so far? Hello. Okay. So the next, let me come over here. So that's a portrait mode, face detection. If you have any camera app in you, like the default camera app nowadays as well, so they have something known as a portrait mode. So what does portrait mode mean? So there is something known as a depth effect. Depth effect. Okay. You can change the depth effect using multiple filters, or there are multiple apps nowadays. You can use a depth effect. Depth effect is nothing but it actually recognizes a human contour first. So if, or your face, or an entire human body from top to down. So this actually helps to first figure out what part of the image you're not trying to apply the depth effect. So that's objective one. The next objective is what part of the image you're planning to apply the depth effect. So that is kind of an inverse of the human contour selection. Then is the application of the depth effect with a certain value. If you consider the value as 0.5, it will be very low, compared to if you consider the value as 1, it will be very high. So that's the basic concept of depth effect over here. So next, if we come to Swiggy, so let's consider Swiggy and Zomato as one example. So now there are multiple places over here. Driver, one is driver, one is the consumer, one is the restaurant. And there is another important segment that over here is the demand forecast from the Uber engine. So what it exactly does over here is like the demand forecast, it will try to predict at what time, when, and where a particular demand of a restaurant is high. That's how the drivers or the riders will go over there to pick up the food. So that's basically the main functionality of Swiggy and Zomato. Along with that, they use a Google Maps engine. So that is kind of what is the fastest time your food will be delivered. So maybe your food will be delivered within 20 minutes, or somehow it gets delayed to 40 minutes. So that entirely depends on the Google Maps recommendation engine. So these are the basic, uh, rather some of the basic uh, day-to-day apps we use. Now we come to Google or Yahoo. Bing works in a separate note nowadays. So when you do Googling or when you search something in a search engine, nowadays it use BERT or something known as GPT-2 or GPT-3. So these are the name of the algorithms, architectures, whatever you call. So what it does is it converts your query. Your query may be, say, uh, your query will be, say, uh, how do we learn machine learning in 7 days? Now this query, so but if you say computer will only understand 0 and 1. So binary bit 0 and 1. So how will the machine understand what is how? So that is a work of NLP, okay, which I said over here, speech recognition, right? Like deep learning plus NLP is used in speech recognition. So this entire message is converted into uh, understandable form. Say there's something known as importance metrics. Importance metrics, which is generally used. This is a generally a higher order matrix or a vector diagram. I don't want to use those terms right now. So that is how generally, so it's a bit more complicated what I've explained right now. So that is how generally a Google search works. Now coming to parcel delivery, again, take FedEx or similar examples who are courier companies who uses regression models. So these models are generally used in two ways. It's again rule plus a machine learning model. So what is the rule? So they have a limit. For transferring the rate for couriering a particular package. The rate will be a fixed rate. Okay. So now where the regression is used. Regression is used if the demand is high, that using regression, this will get increased. So that is how rules plus machine learning is used over here. Any questions so far? Sai, am I
Yeah,
audible?
no, Rehan.
Yeah.
No questions. Your screen share is stopped, right?
Okay. Okay. Let me get back there.
Yeah.
Yeah. Do let me know like when this happens. Yeah.
Yeah. Yeah. Okay.
Can you see the screen now?
Uh, yeah, Rehan.
Okay.
It's visible.
Yeah. Great. So generally, so now talking about the parcel delivery over here. So, as I said, parcel delivery depends on different kind of parameters. The first is rules. Then it comes the machine learning or deep learning part of it. The rules over here is generally the basic cost which is present. Then the machine learning and the deep learning. Using this approach, we can figure out what's the additional cost which will incur over here. Now this is a bit more complicated. The style transfer part, I will touch this part later on. So let's talk about classification. Classification, by the term, you understand you're classifying something into multiple groups, whether it's multi-group or two-group. If it is two-group, that is known as a binary classification. If it is multi-group, it is a multi-classification problem. So this is a domain work. Say right now I'm into telecom domain. If I want to say flag a current customer into a potential user to postpaid, like right now somebody is in prepaid connection. I want to classify who is a potential customer from that prepaid group who will turn into a postpaid user. So that is considered as a binary classification. So similarly, we come to style transfer. It's a bit more cumbersome thing to explain over here right now. But style transfer, say this is my handwriting. Okay, it's very bad. And say if you want to copy this particular style using a deep learning or a machine learning approach over here, you can do that. So there is something known as a style transfer training. Using that style transfer training, you can exactly copy my handwriting. Then if you provide any text, it will represent my handwriting over there. So there are popular style transfers which you can see around. Namely, there is a deep fake image. So if you remember, if you have ever seen, Barack Obama was introducing an MIT or a Stanford lecture. He was opening that lecture. Actually, it was a deep fake image which was made by someone, and they kind of used his image and brought it to life. That's how style transfer works. Now coming to language translation. So this has multiple meanings over here. The language translation can be either from, say, a particular language, English to Bengali, French, Spanish, German. So that is one kind of language translation. Another method of language translation over here is if you have an English language, but it's not pure English. So there are dialects in English as well. If you want to convert that, that can be considered as a language translation as well. So now coming to the fact, so what is anomaly detection, bank fraud detection? So these are, say, if somebody does a s- transfer from your account with, so that you are not aware of it, how will the bank know whether it's you? So there are some prediction models over here which actually says that this is a fraudulent transaction. So one of my patent work is on this itself, where I find out a potential credit risk or defaulters from here. So anomaly detection is again on a very similar line. What we call anomaly is if it is out of general or out of the usual, that is called an anomaly. So so that is something which is predicted by machine learning model. So again, that's an anomaly detection which we do. And I have covered this already. News, that is kind of a recommendation engine which is similar to YouTube, which I have said before. So this had the variety of machine learning and deep learning. So there are tons of examples apart from this, which I have specified over here, which uses machine learning and deep learning. So now coming, so any questions so far? Sai, a quick check, please.
No, no, Rehan.
Okay. Yeah, thank you. So now let me come to some of the top use cases. I won't go into deep because I have already specified some of the sectors. So like customer experience, supply chain, like Amazon. So how the package gets delivered and all those things that comes under supply chain. Then human resource, if a particular candidate is eligible enough for this particular role, that is also nowadays used, like a machine learning model is used, rather a deep learning model is used. Then like fraud detection. in banks, or it can be any credit risk or a loan department. Then knowledge creation, this is something different. I won't touch this right now. R&D, it's the where machine learning used. So if machine learning currently used in physics, medical bioscience, and chemistry. So in most of the researches, machine learning is used. And predictive analytics is again, which say if you're forecasting something, you're forecasting the demand of a particular product or something. So that is predictive analytics. So that's again a machine learning. So real-time operations management. So this is a bit tricky. So this is mostly, you will see an example of a warehouse. In a particular warehouse, you will see there are a lot of real-time things going on. In a product factory line, they use a classical machine learning approach versus a scanning approach to perform this kind of real-time operation management. Then customer service is a very common example. Risk management and analytics, customer insights. Say, being working into telecom industry, I can the rather I cannot see. There are teams who are able to see a customer's reaction or how it works. Then they can flag as a potential risk, or they may be moved to postpaid or downgraded to prepaid. There are multiple things which can be done using customer insights. Then pricing and promotions, you will see, you will get a promotional ad from Amazon Prime, Netflix. So why are you getting the ad? Uh, that is because it's machine learning who is thinking that you might buy a particular ad. So a particular subscription, sorry. So that's how this kind of machine learning or deep learning use cases are. So now let me come to a very core question. What is artificial intelligence? Because to be honest, the answer which I will give, it will be 100% different from internet or someone else you ask, because it's a very controversial topic even today. So for me, artificial intelligence, what it says is, if you can replicate the human intelligence or any particular animal's intelligence, you can call that as an artificial intelligence. So why we compare with the human? Because human has the highest intelligence so far in this planet. So we consider human as the top like section of the species to compare with. So it's like artificial intelligence is a simulation of human intelligence. So now there is a thing. Artificial intelligence is robotics. It's emotions, it's behavior, it's facial expressions. It's a huge field. Like you can jump into multiple fields in AI. So some of the popular fields are expert systems. Expert systems are a particular memory, like a model which is trained, or it is good for doing only one thing. So those are known as expert systems. Or it is good of answering rapid fire questions. So those are expert systems. Then natural language processing. This is for text processing. That's NLP, which was short before. Then speech recognition. So when you talk to Google Assistant or you record something and you want it automatically, it gets converted to or digital text. Deep learning or machine learning models are used over there as well. Then the popular one, which we generally see day to day, is computer vision or a machine vision. So both are same or and used interchangeably. So this is, you can use Google Lens, then face detection. Then if you like cross the speed limit, they capture your number plate and zoom to the number plate. So how are they identifying this is a number plate? So that's again a machine learning and a deep learning approach which they follow. Okay. So now, so if you see, I will in the next slide, machine learning is a subset of AI. So AI consists of many more things apart from machine learning. Machine learning is that machines are intelligent. But in artificial intelligence, there are many other things which falls under AI. Now, this is a very simple chart, like which you can give a quick through. So the top, yes, I,
Sorry, Rehan. There is a
yeah.
question: how
Yeah.
AI is used in the banking sector? Banking
Okay.
sector.
Okay. So now, so banking sector is a very broad question. So I can specify few of them. Say in banks, uh, so there is a loan department. Okay. So you can say whether a particular customer is eligible for loan or not. Using machine learning, I can predict. Okay. Whether a particular customer will be a defaulter in future. So you're predicting in future whether he will be a defaulter or not. That's also a machine learning approach. So, so these are some examples in loan. Now coming to a credit card department, for example, say how will you justify or like categorize a customer into which kind of credit card he should carry? One is say the annual income. Apart from that, there are other things which the company looks into. How you behave, how much you shop. The more you use a card, say you earn in lakhs per month, but you hardly shop anything online. So giving you a high privileged card or high privileged credit card is a waste of money for them. Okay. So it's better to invest on someone who spends more than 50,000, but the earning is around 60,000. Okay. So that's a better customer compared to the one who earns 1 lakh per month, compare and spends around 10,000 per month. Okay. So that's not a good customer. So all these things are generally analyzed under credit card department. So there are other things, frauds. There are fraudulent transactions can happen. If somebody performs, say right now you do 5 transactions in Chennai or in your place, maybe in Guntur or somewhere, and you that immediately that same card is withdrawing the money from Kolkata ATM. Okay, so you will receive or your transactions will be blocked immediately, saying it is not logically possible for you to transfer the card from Guntur or Chennai to Kolkata within 5 minutes. So that's a anomaly or that's a fraud. So that is also a tagging. Machine learning continuously does that. It's not machine learning. There are advanced concepts like quantum theory or quantum computing also helps over here. Is it clear or do you need more examples in this domain? Please do let like in the chat make it aware. Okay.
So it's clear, Rehan. There is another question.
Yeah.
Uh, Better I will give the chart access for that guy because there is a big question.
Okay. Yeah.
I
Go
will give
ahead.
the
Yeah.
chart access. Yeah, yeah.
You can just read it out real fast if you like.
Okay, I will read it out. So, well, we are supposed to come to technologies. Well, coming to artificial intelligence, there is a stigma associated with the kind of domain. There is good and there is bad. Just like the times of industrial revolution, people use it to oppose the mechanics used for industries over humans. Well, how to encourage them to fear less of AI? What's the future of AI? Well, like all the jobs that left occupied by A. What is your view over the situation that I have mentioned?
Okay, okay. Yeah, I will come to that point around after next. Like, let me cover 2 or 3 more slides. I will come to that point. That's a very important thing, and this is always in this discussion whenever new technology or line comes up. So I will surely let you know. So now, coming to the basics, like first, let me talk of the basic differences. What is AI? What is ML? What is deep learning? And what is data science? So I consider myself as a data scientist. So what exactly is data science? So AI is the entire area of this computer science. So if you consider AI is more of a subject. It's a stream. Computer science is a big stream that is AI. Then is machine learning. Machine learning is a subset of AI where a model or a mathematical model, to be more precise, starts to learn from the data. So there are better examples I will give you in future. So deep learning is again subset of ML right now. So this is a certain category of models which is coined as deep learning. So it is not the the classic statistical based models. This is a different stream or different type of models. That model is known as a deep learning model. But if somebody refers a deep learning model as an ML model, is absolutely fine. But if somebody refers a classical machine learning model as a deep learning model, it's wrong. So the vice versa is right, and this one's wrong. So data science actually uses all of this to gain insight from the data. Say, if you consider the term scientist, we are the kind of scientists for the data. Say, if you give me a data using machine learning, deep learning, AI, all three, all available approaches or techniques or tricks, I will try to gain some insights. Okay, so that what data scientists do in day to day. So I will give you some examples about my day-to-day job at the very end. So that is data science. Also, these are some of the topics for like artificial intelligence. So if you see sensors are generally take example of cars, Tesla. Tesla use multiple sensors that comes under AI. Robotics. Okay, then linguistics, like language, like the one say if you make a model or a very general model that is known as a general AI, which can understand 10 different languages or can speak in 10 different languages, those will fall under AI. Then comes machine learning. So there are SVM, is a very classic machine learning model. Then KNN. So these are different name of the models. So this performs either a classification or a regression. So these are the models. Then there is text mining, time series forecasting. So time series forecasting, which I heavily do in my company right now. So this is a mix of AI and machine learning. So this is very closely related to AI, but there are some machine learning roots as well to time series. Then we have classical studies. So to be a data scientist, you need to cover deep learning, machine learning, as well as artificial intelligence, all in all. Addition to that, you have to know statistics, visualizations, then experiments, coding. Like it's a big sphere which you have to cover. So now, what is machine learning and why there is so much hype about machine learning over here? So machine learning was invented later compared to deep learning. Okay, so this is something to keep in mind. Deep learning was invented not way before, but before machine learning. So, but machine learning became popular compared to deep learning because that time the system, the computation power was quite low. So that's the reason machine learnings are popular over deep learning. But as the days passed on, using Moore's law, the kind of uh, computation got increased. Okay, then deep learning started kicking in and it's performing much better nowadays. Okay, so now coming to the question which someone asked about the stigma and all those things. Yes, I.
There is another question. Machine learning is
Yeah.
spreading into the banking sector widely. Why still ATM frauds are taking place?
Okay.
Fraud.
See, like, yeah, see, there is no uh, perfect solution for a non-fraud design. So whenever say this is a particular level of security, all the hackers or the fraudsters will go one step up, okay, and do the fraud over here. Then again, the security researchers will enhance this to cover this and some more and try to develop another system. Again, the fraudsters will go from there. It's a continuous evolving. So there is no perfect solution in the market for anything considered like that. Okay, there is always some so new ways to hack, new ways to do a fraud, and there are new algorithms which are kind of covering that. But now if you compare the real market, if you see if in research which is happening in 2022 that gets implemented in so many ATM machines by say 2025. So it the research or the advancement is lacking 3 years over here. Okay, so that's a very common thing because it takes time to adapt. So whenever you will come to an industry, you will understand it's not like whatever you wish you do. It takes time to adapt all these things over years and years. Okay, so that's the main reason. So there is always a competition who is doing better in the market. So on this note, I will answer one more thing, like one more question which is there. So the stigma. See, like, of course, the demographic of jobs are changing. So previously, when machines were coming in, the automation tools, okay, the sewing machine were automated. Previously, it was hand sewn. Then it became an automated machine. So there will be a group who will be unemployed, of course, like there is no question in that. But there should be an effort from themselves or from the society to incorporate them into the new technology. Let's take an example. When somebody was working on Fortran, it's a very it's a very old language. Okay. Then somebody jumped to C, then C++, then Python. Okay. Oh, sorry, there is Java in between. Java, then Python. Okay. So if somebody is just into Fortran, then you cannot expect him or her to gather or like transfer to Python directly. It's tough. Okay, to adapt the market. So it's always better to evolve as the market evolves. So right now I am into data science, I know machine learning, but I am also learning ML ops. That's the operational side of machine learning because I see that there is a demand over there because you have to learn yourself through the demand. And if somebody is afraid of jobs, like jobs, threatening of jobs, I feel every industry sees change. This industry is seeing a change, and slowly everybody is adapting also. So it's not a major problem, but yeah, you have to adapt. Okay. Okay. Uh, so that's the problem in terms of the job security.
So there is another
Okay.
question that is,
Yeah, sure. Go ahead.
apart from ML, is any other subset present for AI?
Yes, there are. There are robotics as well. The entire robotic stream. There is an entire time forecasting stream. There are the entire, if you consider the expert engine, the expert systems, that's an entire field again, all over. Okay. So that is so, but right now we are more focused on ML, obviously, because this is a talk about deep learning. That's why we are focused. But yeah, there are other fields apart from this. There is generalized artificial intelligence. So that's the ultimate goal for all. Even for me, the ultimate goal is generalized artificial intelligence. Okay. Or generalized machine learning. That's the final goal. Okay. So again, back to the slides. So right now, the screen which you are seeing is types of machine learning. So, so there are mainly three types. These are the three major types, and this one is a reinforcement learning. I will explain in a very brief. Supervised learning is something when you get the entire data, okay, which is a structured data, you call or do classification, that is a supervised learning. Unsupervised learning is something when you do clustering, when the data is not structured. Semi-supervised learning is kind of mix of these two. So that is like why the term is semi-supervised. It's a mix of structured and unstructured data. And reinforcement learning is something if somebody is into games recently, there are a lot of games which learns to play by themselves. Okay, like Super Mario, then there are like some racing games as well. I forgot the names. So you have an algorithm which is trained in generations and they learn by themselves. That is known as a reinforcement learning. Okay. So these are some basic types. So now before diving into what is deep learning, the basics of deep learning, I will try to explain some biology related to it. Okay. I won't go in details because I'm not a bio student. I'm not good in this as well. But if you have ever heard what is a neuron are kind of the basic nerve cells for the brain, for the nervous system. So it has this kind of a structure. In deep learning, we try to replicate the same structure. So dendrites are, so this is in synapse, synaptic fluid, if you have ever heard of. So these are the dendrites over here. Okay. This is the main nucleus where the processing happens. This is, see, this gets transmitted over here through axon and it gets, it moves to different similar neurons again. Okay, so that is a concept of, or a basic concept of a neuron. In deep learning, it's again the same thing. There are multiple inputs. There is a processing layer. I will come to a bias later on. There is a processing layer, and these outputs are again fed into multiple neurons, or this is the final output. So that is what neuron is over here. Okay. Okay, now this is a very detailed slide of how actually a neuron looks. If somebody is into maths or if they like it, I feel you might get more insight. So neuron is actually a mathematical operation which takes in X. These are the input values, these are the weights. So now compared to the last image, the weights are over here, W1, W2, Wn. Okay. So we take the weights. Now we do a multiplication. So how it looks, x1 w1, and this is a summation, plus x2 w2 plus x3 w3 plus dot dot dot. What is over here? N, xn wn. Okay. So now this is a single value. This sum pushed into something known as an activation function. Activation function we represent, say, like for example, we represent by x. This activation function will say whether to activate this neuron or not. So, so what do you mean by what do you mean by activation function? Say you have a neuron. Say consider this as a neuron. This is a very rough diagram. Please don't judge. So say this is a neuron. So do you, if this neuron has no activation, it's equal to there is no neuron. But if there is an activation, this neuron will pass some value, maybe 1.5. As this is a summation, this will be in decimal floating points always. Okay. So this is, I don't want to go in details because this is kind of mixed. So I don't want to go in details. So now coming to what is deep learning. Okay. So this by itself, if you consider this one by itself, this is a perceptron. So this is also something which you will see, perceptron. Okay. This is a very basic building block of deep learning. And this is a neuron, this concept. So deep learning is when you have multiple neurons, when you have, say, there are three inputs over here, three inputs into four hidden layers into two outputs. Okay, 6 into 4. So these are the kind of neurons for this model over here. This model has around 6 to 12, 24, 24 neurons over here. Okay, this model. Because how I can say 24? Each has a different connection over here, if you see. So this permutation combination gives rise to a lot of combinations over here. Okay. Now you know what is a neuron. Neuron biologically is a nerve cell, is a basic thing of a nerve cell. So if you see, these lines are human is on the top, which is 10 to the power 11 neurons, and the lowest is sponge, which is 10 to the power minus 2. Okay, so 1 by 100. Okay, so these are the kind of algorithms which took place and how we are going closer to the number of neurons compared to humans. So right now, say in 2021, it's close to octopus. It's did not cross octopus, but it's close to frog and octopus. Okay, so nearly it's now 10 to the power 8 neurons which we have right now. So this is the progress we made so far. So more the neurons, more how can I say, more intelligent the model can be. Whether it will be, nobody is sure, but it can be. Okay. So this is the kind of uh, what to say, the uh, the trajectory, or so if you see the trajectory, it's mostly like this. Okay, so right now there is a chance it will get stable until and unless like there are some huge advancement real fast, like quantum, like deep learning comes into picture, it will be low as of now. Okay, any questions so far, say?
Can AI predict its own gradual development? There is a question called
Can
can
AI?
predict its own gradual development.
Yes, it can predict. Of course, it can predict, but again, that's mostly a statistical analysis. So, it if you can search this, there are predictions which AI only made. What will be, rather, how will AI look in 2050? AI only made that prediction. Okay. So see, now you have always have to take these answers with a grain of a salt. Like it's not always 100% accurate. Okay. So keeping that in mind, yes, it can predict logically because there is a substantial data which you can train the model with, and you can expect the output. So it can predict logically. But whether it's a right prediction or a wrong prediction, that's a question to discuss. Got okay. Now, I won't touch on this topic much. It's a very quick. So this is history of deep learning, machine learning, whatever you call. If you see, perceptron is something which got developed earlier. Neural network is something which got developed earlier. Then came the classical machine learning approaches, decision tree, SVM, random forest, adder boost. Then this is perceptron large scale. Large scale means when the computation is very high. Okay. So, and the red line which you can see over here is the line for deep learning. Okay. Nowadays, if you continue this, deep learning has a popularity over here in 2022 at least. Deep learning has higher popularity overall. So that's how the chart looks like. Okay, this is an important topic and I want to spend around 5 minutes on this slide. So these are the recent advancements. So I will touch on some, but if somebody has like want to know something extra, please let me know from this slide. I will talk on that as well, but I will touch only few points from here. Okay. The first one, which I had already talked about, is spoken language, speech recognition. So whenever you talk to a model, it automatically recognizes your voice, the type of voice, and it converts to a text. That is mostly a spoken language. So, uh, like, what to say? This research is going on over here. Now, coming to music information retrieval, if you have used uh, Shazam, right? If I'm not remembering right, Shazam is this one application, and in Google Assistant also you can recognize musics. Okay, what song it's playing? It actually uses music information retrieval systems to understand that. Then game playing. Game playing is part of RL. RL is reinforcement learning, where it actually learns how to play a game. This is again a field of research right now. Then coming to transparency explainability. So deep learning model, if you already saw, it's extremely mathematical. Okay, over like this. So how will you kind of predict it, like, or interpret the result? So there is and I also work on this area a lot. So how can you say how well it performed, or how can you say the output is right or wrong? So these are the kind of things which is working the explainability and the interpretability area. Fairness and debiasing is again a transparency also. This comes here as well. So let's consider, uh, you just visualize somebody is rock climbing. Okay. By default, you will think that particular character is a guy, a male. Okay. So that can be a female also, because anybody can do a rock climbing. It's not demeaning their physical strength. Anybody can do rock climbing, or anybody can do, say, if I say cricketers, first you will think of a male cricketer, not a female cricketer, because we are biased like that. We see male cricketers more compared to female cricketers. It's nothing wrong with us, but how the information is fed to us. Similarly, there is a problem with machine learning also. In machine learning, when somebody is like feeding this kind of data, machine learning starts assuming that, or rather, the machine learning starts biasing. If I complete the sentence over here, then say, or okay, let me put it in this way. You made a model which predicts the number of crimes. Okay, in a particular city, you will see mostly the crime is by a male gender, but crime can be committed by a female gender as well. Okay, so this is a bias which gets incorporated from the data. So this is a very important field of research nowadays, like very important field of research. Then I have talked about vision and image modeling a lot. Like written language, yeah, I had talked, like translation, conversation, like if you're talking with a bot like Google Assistant, it's kind of you're conversing naturally. And generalization is something which I was talking at the beginning. So this is like the ultimate goal of machine learning AI. That's generalized artificial intelligence. And security is again, which I had word, like say anti-malware softwares or antivirus softwares, or anti-piracy, then frauds. These are all safety and securities. So any questions so far, or do you want anything to be covered over here a bit more? Hello? Hello, am I audible? Hello?
Yes, sir,
Like,
you're audible.
okay. Yeah, do give a heads up. Yeah, please. Any questions? Yeah, I saw one, maybe anti-malware. Okay. So I'm not a security expert, but I can speak a little, of course. Say this is a file which has a which is a normal file. This is a file which is kind of corrupted. Okay. And this is a file which has a malware in it. Okay. This is a malware in it. Okay. This is a normal file. This is a corrupted file. So a particular machine is trained with which is a normal file and which is a malware file, okay, and which is a corrupted file. So a machine learns with thousands and lakhs or millions of example, like which is a normal file and which is a malware file. Then, if you give a normal file, or if you give a file, just a file as an input to that model, it can say whether it's a malware file or a normal file or a corrupted file. It can classify. So this is a classification problem, but this can be a advanced quantum problem as well. Recently, I don't know much about quantum in this field, But yeah, there are quantum mechanics which is used in this field as well. Okay. So now coming to, so I'm kind of coming to the end of the presentation. So this is object identification. Now these are some examples. If you see, this is a mite. It kind of with low confidence level, like says it's a mite. Sorry. Then it says a black widow spider. Then it says a cockroach, a tick, and a starfish. This is a model which gives, so this is known as an object identification. Same, this is a container ship. It says a lifeboat, amphibian, fireboat, and a drilling platform. It did not mention that this is a sea. Okay, it's like this. So you can see there are a lot of examples. Like this is a very good example. It sees a Dalmatian and it sees cherries over here. So it says Dalmatian and grape. It does not say cherry, but it's close. Like you can forgive that much. So this is a very good example of object identification which is happening. So these are some of the popular models. I'm not going into details. So why I keep this image? So this is a human performance. Okay. If somebody is given a particular image, a human can identify this properly. Human can identify this properly. Okay. So, but recently there are some algorithms which are performing better than human. Okay. Who decided this particular error rate for human? This 5% error rate. It's again very tough to say, but there is a test known as a Turing test. Okay. So using Turing test, we found out that humans with that subset has a 5% error rate, but these models are lower than that. That's what it is. If somebody is interested, they can search ImageNet and they can have all the details from there. So now if you say, if machine learning this perfect? No, it's not. Let me give an example. This is a truck. Okay. This is a bird. This is a temple. Okay. If you add a noise, this is known as the noise over here. This is a noise over here. This is a noise over here. If you add a noise, somehow this particular bus becomes an ostrich. This kind of a bird becomes an ostrich. This temple becomes an ostrich. Same. This is a panda. This is again a noise. If you add this becomes a gibbon. There is no sense. This is a dog. If you add a noise, it becomes an ostrich. There are other examples. Dog, noise, ostrich, panda, this gibbon. These are known as adversarial attacks. Okay. There is a very good paper, 1 pixel attack. So in an entire image, they only change 1 pixel and the entire prediction of the model gets changed. Okay. So there are drawbacks as well. Like it's not perfect. Again, I am saying. Okay, there are drawbacks. So any questions so far? Because I have one more segment left. Then it's any questions? Okay.
Sir,
I'm moving forward. Yeah. Yes, I.
Yeah, sir, there are no questions right now. You can proceed.
Okay. 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 Great. So, so coming to speech recognition, WER is word error rate. Okay. So again, consider this particular line as a human line. Like let's consider that. Let's consider this as 5%. So if you see, this is speech recognition. See, there, if you listen to a song, can you understand all the words from that song? Yes or no? If you can understand, that is speech recognition. So the same thing is performed by a deep learning model or DNN. Okay. So better it performs, the better model it is. Or in other words, the less error it gives, the better model it is. Okay. So these are again the red dotted line. So it's around 5%. It's the human intelligence and sorry. Yeah. Okay. Let me just zoom out once. Okay. If I just zoom in over here, if you see recently around 2017, there are around these two models who performed better than human intelligence. ResNet plus by LSTM's acoustics plus Microsoft 2016B. Okay, so these are kind of what to say, the state of the art uh, speech recognition model. So you will find similar graphs for different algorithms or models. So, or sorry, different subtopics as in speech recognition, then image recognition, object identification, like this. So you can take a look which algorithm is performing better at that time. So these are some of the references which I've used. Yeah. So this is kind of end to the session. Uh, any questions?
No questions up to now, Rehan. So there
Okay.
is a question in the chat like nowadays ML is used in weather forecast, but why if they say today it is going to rain, but it will be sunny like that? Why
Okay.
it will
I-
change?
Okay. It's okay. There are two answers. Let's consider like this. The first answer is instrumental error. Okay. The second is human error. Okay. And the third one is the variable factor. See, predicting a weather is very tough. I'm emphasizing it this much. Predicting a 10-day weather is extremely tough. You see just in the phone what's tomorrow's weather, but in actual life, it takes around hundreds and hundreds GB of RAM, hundreds CPU power, over 2 hours or 3 hours of computing for single day prediction. It's that tough weather prediction. It's not easy at all, to be honest. Okay. So variables as such, humidity, then these are the basic variable, temperature. So change in this, we generally do predictions, but there are other things as well, like pressure, atmospheric pressure. If there is current, wind currents, moisture, like the humidity which I mentioned, did something event happen before? Say there was a kind of a burning event, like somebody was burning lot of pollution. So that kind of event can trigger a change in weather. So it's extremely complex. So see, it's not just machine learning faults, but there are some instrumental errors as well. Now, what is an instrumental error? Instrumental error is a machine reads a particular temperature as 29 degrees Celsius, but it actually is 28.79 degrees Celsius. Okay, it kind of performed the whole number and made it 29. These are all instrumental errors. So there are scientific instruments which have very high precision in terms of giving the result. But if you use a low scientific equipment, the error rate is higher. That's how the prediction is bad, worse. And human error is when a human wrongly enters the numbers. So, but nowadays this factor is very low. It's very low. Okay, because everything is automated nowadays, at least in major countries right now. I hope that answered the question.
Yes, Rehan. It's
Any more questions?
so no questions.
Okay, I can give around, we can at least. If you have any questions, apart from this slides also, if you have any questions, you can ask on MLDL, data science. Any questions, Sai?
So there is a question like,
Yeah.
is there any best resource or any course to learn deep learning?
Yes, see, very popular is a Andrew Ng course in Coursera. That's a very popular one and it's a very good one.
Okay.
Then there are a lot of books. Okay. So if
Okay.
you want a very proper deep learning book, okay, the book which I have written is very bad compared to that, of course. So that book is by uh, it's let me think. It's the name of the book is Deep Learning. If you can search the name Deep Learning, it's the name is Ian Goodfellow. Yeah, Ian Goodfellow, and it spells like this. Ian Goodfellow, GWDFELLO, Ian Goodfellow, Deep Learning. Those books are the books for deep learning right now. Okay. Any more questions?
Uh, no questions.
Okay. We can wait for a minute, then we can close it if there are no more questions.
Yeah, okay.
Or do you want to discuss on something else? We can have a discussions as well. If somebody wants to discuss on something. Any more questions?
No
Is there any
questions.
resources and people where can AI predict gradual development, ATM frauds? Okay, this is the okay. Yes. So if there are no questions, then yeah, we can close. Or if you have something, please do let me know. Or you can reach me over LinkedIn. Like if you have any questions, you can it's just Rehan Guha. In LinkedIn, you can search, you can reach me there. If you have any questions, just drop me a message. Whenever I generally answers most of the questions of all, but it might get delayed sometimes because of my day-to-day chores. Okay. Yeah, then I feel it's good to close the call. Right, Said?
Yeah, okay. Let us end up this meet, Rehan. Thank you for come to the meet and give it a talk on deep learning.
Yeah. Thank you very
Thank you, Rehan.
much. Thank you. Bye
Yeah,
bye.
bye. So let us end the meet also. Let me end.
Okay.